Horizontal heat. Background. Fireplaces and stoves burn fuel to produce heat. 80 to 90% of this heat goes straight up the chimney without warming anything or anyone except the environment. The well-known limitations of fireplaces were mitigated in part by building and fueling multiple fireplaces at considerable expense. An electrical resistance space heater converts electrical energy into heat and includes a fan. The fan can move heat horizontally, but it is inefficient. A few feet away from the space heater or fireplace, there is very little airflow and heat. The heat tends to rise vertically, not spread horizontally. This is a hot plate, $11 at Walmart, containing an electrical resistance heating element very similar to the eye of an electric stove. I was surprised to find that the hot plate can easily produce very high temperatures. Here we see 758 degrees Fahrenheit, but I later obtained 888 degrees Fahrenheit with this same hot plate. So why don't we just add a fan to a hot plate for abundant high heat? We don't do this because children and pets could easily get hurt or start fires. In these examples, the fireplace, the space heater, and the hot plate, we see two basic principles that have severely limited heating for millennia. The first is that heat rises, generally vertically, and the second is it's hard to move air horizontally. What we have is heat that rises vertically, but what we need is heat distributed horizontally. All three devices, the fireplace, the space heater, and the hot plate, are very good at producing heat. They are very poor and inefficient at distributing heat horizontally. This produces the need for what I call horizontal heat. Horizontal heat captures solar radiation, wasted heat from chimneys and fireplaces, and electrical resistance heating elements to warm homes. It moves the heat generally horizontally, not vertically. There are two ways to do this. The first one uses simple fluid pressure. It's called heat transfer device. The second one I named dynamic fluid leveling, or DFL. They both involve heating and moving a liquid, not air. It's hard to move air horizontally, but much easier to move a liquid. They are both patented. In the next few minutes, you will see two new ideas that will greatly improve heat efficiency while lowering its cost. They will also enable radiant solar heat to be moved from outside, where it's currently unused and wasted, to inside, where it's needed. To readers with a science background, this presentation may seem slow with too much detail. I request that you make allowance for those who may be unfamiliar with the working concepts of heat and pressure. These may be the first significant advances in heating and heat transfer in thousands of years of history. They will improve the efficiency and lower the cost of heating your own home. Together, I call them horizontal heat. Part the first, fluid pressure, heat transfer device. This simple closed circuit is the heart of the invention. It is a conduit filled with a working fluid with two valves as shown. We heat the portion of the conduit between A and B. We can heat it with solar radiation, a coil placed on a flat plate in the sun, even the winter sun, disguised as yard art, or with the hot plate, up to 888 degrees Fahrenheit. Suppose the pressure relief valve is set to open at 100 psi, pounds per square inch. The heated working fluid is trapped between the two valves. As it heats, it expands, or tries to. The pressure between the two valves increases to 100 psi, and the pressure relief valve pops open. When the pressure relief valve pops open, several things happen very quickly. First, a pulse of hot, pressurized working fluid is forced clockwise through the lower blue portion of the loop, from B to A. Secondly, the pressure of the remaining fluid between the two valves, A to B, falls. The precise level to which it falls is determined by the pressure relief valve and is called the reseating pressure. For this example, suppose the reseating pressure is 20 psi. So we have a pulse of hot, pressurized working fluid being forced clockwise through the conduit at about 100 psi. The working fluid remaining between A and B is at 20 psi. The pressure of the pulse of hot fluid falls as the fluid travels through the conduit due to fluid friction. Some sample pressures are shown. We see it falls to 75 psi, then 50 psi. As the pulse reaches the one-way check valve, there is 30 psi, for example, on one side and 20 psi on the other, so the pulse is forced back into the AB portion. The process and the cycle repeat in an endless loop. Here is the sequence. First, the fluid between A and B is heated by solar radiation or an electric heating element. Second, the pressure within AB builds. Third, the pressure relief valve pops open. Fourth, the heated fluid is forced clockwise through the conduit, losing pressure along the way. 5. The cooler, lower pressure fluid re-enters the AB portion through the one-way check valve. Number 6, return to step 1 and repeat. It is transferring heat, either from the sun, an electrical resistance heating device, waste heat, or other, to a cooler space, where it rejects the absorbed heat and warms the cooler space. If heated by solar radiation, it consumes no user-supplied energy. Capturing solar radiation. The heated working fluid warms either space heaters, baseboard heaters, radiant heat flooring, or a crawl space. The flat plate may carry yard art with the coils on the underside out of sight. For a chimney, here we are at Cracker Barrel, which always has a nice stone fireplace. The conduit loop is coiled around the flue inside the chimney. The flue is actually a rectangular terracotta pipe. This is actually the chimney itself. What we think of the chimney is actually the facing for the terracotta flue. The conduit is filled with oil and thermally insulated, think cooled noodles, across the ceiling and down the wall to underfloor. It captures some of the heat going up and out of the chimney, currently completely wasted, and routes it underfloor. Capturing fireplace heat. Placing the fireplace outside the house increases the capture of heat with a flat plate and housing and decreases indoor smoke, irritants, dehumidification, risk of fire, fire insurance, etc. It also keeps fuel and ash out of the house. Part the second, DFL, Dynamic Fluid Leveling. This slide is actually a composite of 4 separate slides. In the upper left-hand corner, we see an illustration of Aristotle's principle that water seeks its own level. Any liquid added to that system, whether at A or B, raises the level on both sides of the conduit. In the lower left-hand corner, we see that this works regardless of either the length or the configuration of the conduit. That configuration could be 30 feet high, it could be a mile wide, it's all irrelevant as long as A and B are the highest points in the loop. In the upper right-hand corner, we see that moving a cup of water from A to B, pumping it, causes all of the water to move. The pump could be very small, and the conduit could be very large, thousands of feet large. In the lower right-hand corner, we see that this works because it can't not work. That simply cannot exist, that A and B are at different levels. This is the basis for DFL, dynamic fluid leveling. It's kind of elegant in its simplicity. The conduit may be asymmetric. A small weatherproof housing, like a plastic box, keeps the working fluid from evaporating to the atmosphere. The working fluid never needs replenishment. Capturing fireplace heat. As above, placing the fireplace outside the house increases the capture of heat with a flat plate and housing and decreases indoor smoke, irritants, dehumidification, risk of fire, fire insurance, etc. It also keeps fuel and ash out of the house. Capturing solar radiation. This will also work with the solar absorbing plate described as yard art mentioned above, the outdoor fireplace, and the chimney, all mentioned above. This will also work with the electrical resistance heating element mentioned above. Also, similar to the above, DFL, dynamic fluid leveling, uses an electrical resistance heating element to heat water within the conduit, which is distributed generally horizontally throughout the living space at fuel cost zero. This is horizontal heat. These are two ways to move heat, generally horizontally. They move heated water, which is easy, not air, which is hard. For more information, please contact John Saavedra. My email address is my last name, Saavedra, at mindspring.com. More ideas at lookforthepower.com. Thank you.